Hello friends, in this video we shall discuss indeterminate form. Dear friends, if you are new to this channel, please subscribe the channel and don't forget to press bell icon so that you can get updates of this channel. What are the indeterminate form? If two functions fx and gx are both 0 at a point x equal to a, the fraction fa by ga is said to assume the indeterminate form 0 by 0. The two functions fx and gx both are 0 at a point. This implies that the fraction fa by ga assumes indeterminate form, that is 0 by 0 form. Although the function capital Fx equal to fx by gx, capital Fx is undefined, that is indeterminate at x equal to a. It may, however, approach a limit at x approaches to a. Though function is undefined, its limit can be obtained. The process of determining such a limit, if it exists, is known as evaluation of indeterminate forms. For that, L'Hospital rule allows the evaluation of indeterminate forms. What is L'Hospital rule? Let fx and gx be continuous in an interval CD containing x equal to a. Suppose fa equal to 0 and ga equal to 0. F at a equal to 0 and g at a equal to 0. Both the functions become 0. Also, the derivative of f and g exists such that g dash x is not equal to 0 in open interval CD, except possibly at x equal to a. Then, limit x tends to a of fx by gx equal to limit x tends to a of f dash x by g dash x. We shall revise L'Hospital rule. Let fx and gx be continuous in an interval CD containing x equal to a. Suppose f of a equal to 0 and g at a equal to 0. Also, the derivatives of f and g exist and g dash x is non-zero in the interval CD except possibly at x equal to a. Then, limit x tends to a of fx by gx equal to limit x tends to a of f dash x by g dash x. This is the L'Hospital rule. Provided the limits on RHS of this equation 1 exist. We shall prove this. Since fx and gx are continuous in open interval CD, f of a equal to 0, g of a equal to 0 and f dash x exists, g dash x exists, the functions fx and gx satisfy the conditions of Cauchy's mean value theorem in open interval CD. Therefore, we have f of x minus f of a divided by g of x minus g of a equal to f dash e divided by g dash e, where e belongs to open interval CD such that x is less than e is less than a or a is less than e is less than x. From the hypothesis f of a equal to 0 and g at a equal to 0. So, fx by gx equal to f dash e by g dash e. Substituting the value here, f at a equal to 0, g at a equal to 0. Therefore, we will get fx divided by gx equal to f dash e by g dash e. As x tends to a, e also tends to a. So, we have limit x tends to a, f of x divided by g of x equal to limit x tends to a of f dash x by g dash x. This proves the L'Hospital rule. Note that in right hand side of equation 1, the function fx and gx are differentiated with respect to x separately and not by using the quotient rule. Corollary 1. Suppose f at a equal to 0 and g at a equal to 0. In addition to f of a equal to 0 and g at a equal to 0, applying Cauchy's mean value theorem to fx and gx, we get L'Hospital rule as limit f of x by g of x, f dash a equal to 0 and g dash a equal to 0 in addition to f a equal to 0 and g a equal to 0. Suppose Corollary 1. Suppose f dash a equal to 0 and g dash a equal to 0 in addition to f a equal to 0 and g a equal to 0. Then, by applying Cauchy's mean value theorem, f dash x and g dash x, we get L'Hospital rule as limit x tends to a of fx by gx equal to limit x tends to a of f double dash x divided by g double dash x. Corollary second. If f a equal to 0, g a equal to 0, f dash a equal to 0, g dash a equal to 0, f double dash a equal to 0, g double dash a equal to 0, fn minus 1 a equal to 0, gn minus 1 a equal to 0, and gn a is non-zero, then L'Hospital rule is limit x tends to a of fx by gx equal to limit x tends to a of fnx by gnx. Fnx is the nth derivative of f and gnx is nth derivative of g. Corollary 3. As x tends to infinity, if fx by gx assumes indeterminate form 0 by 0, then L'Hospital rule is limit x tends to infinity of fx by gx equal to limit x tends to infinity f dash x by g dash x. Indeterminate forms of the type infinity by infinity. Suppose fx equal to infinity and gx equal to infinity as x tends to a, or x tends to plus minus infinity. Then fx by gx assumes indeterminate form infinity by infinity, which can also be evaluated by L'Hospital rule. Limit x tends to a of fx by gx equal to limit x tends to a of f dash x by g dash x, or limit x tends to plus minus infinity of fx by gx equal to limit x tends to plus minus infinity of f dash x by g dash x. Results similar to corollary 1 and corollary 2 are valid in this case also. That is, limit x tends to plus minus infinity of fx by gx equal to limit x tends to plus minus infinity of f double dash x by g double dash x. Next, limit x tends to plus minus infinity of fx by gx equal to limit x tends to plus minus infinity of fnx by gnx. One important note: while evaluating the indeterminate form infinity by infinity, in many cases, it is advised to convert the indeterminate form infinity by infinity to the form 0 by 0 as early as possible, say by rewriting as fx by gx by 1 by fx divided by 1 by gx. Otherwise, the process of differentiation of numerator fx and numerator gx may never terminate, which complicates the problem. So, in many cases, infinity by infinity problem can be converted to 0 by 0 problem. We shall see while solving the examples. Next form, form 0 into infinity. As x tends to a or x tends to plus minus infinity, if fx tends to 0 and gx tends to infinity, then the product fa into ga is undefined and is said to assume the form 0 infinity, which is indeterminate form. This can be converted to indeterminate form 0 by 0 or infinity by rewriting fx into gx equal to fx divided by 1 by gx or gx divided by 1 by fx, and applying L'Hospital rule, indeterminate form infinity minus infinity. As x tends to a or x tends to plus minus infinity, if fx tends to infinity and gx tends to infinity, then the difference fa minus ga is indeterminate form of the type infinity minus infinity. Rewriting the difference into the fraction of algebraic means, for solving such types of problem, fx minus gx can be expressed as 1 by fx minus 1 by gx divided by 1 by fx into gx, which is 0 by 0 form. Applying L'Hospital rule, the indeterminate form infinity minus infinity is evaluated. Indeterminate forms of the type 0, 0, infinity 0, and 1 infinity. As x tends to a or x tends to non-infinity number, The expression fa into ga is said to be indeterminate form of the type 0 raised to 0 if x tends to 0 and gx tends to 0. Indeterminate form of the type infinity raised to 0 if and only if x tends to infinity and gx tends to infinity. Indeterminate form of the type 0 0, infinity 0, 1 infinity. As x tends to a or x tends to non-infinity number or x tends to finite number, the expression fa into ga is said to be indeterminate form of 0 raised to 0 if fx tends to 0 and gx tends to 0. Indeterminate form of the type infinity raised to 0 if fx tends to infinity and gx tends to 0. Indeterminate form of 1 raised to infinity if fx tends to 1 and gx tends to infinity. To evaluate these forms, consider yx equal to fx raised to gx. And then taking logarithm of both sides, we will get ln of yx equal to gx into ln of fx, which is of the form 0 infinity and can be evaluated as in indeterminate form type 0 infinity. Taking the limit as x tends to a, limit x tends to a of ln y equal to k suppose, and k equal to limit x tends to a of ln y equal to ln of limit x tends to a of y equal to ln of limit x tends to a of fx raised to gx. Therefore, limit x tends to a of fx raised to gx equal to e raised to k. Note, Maclaurin series expansion may be used to simplify the expressions. And second note, standard limits such as limit x tends to 0 of sin x by x equal to 1, limit x tends to 0 of tan x by x equal to 1, limit x tends to 0, 1 plus x raised to 1 by x equal to 1 may be used. Now we shall try to solve some examples. First example, evaluate limit x tends to 1 of 1 plus ln x minus x divided by 1 minus 2x plus x square. If we put x equal to 1 here, we will get 1 plus log of 1 0 minus 1, 1 minus 1 0, fx becomes 0, and 1 minus 2 into 1 plus 1 square, this is 0. Therefore, this is 0 by 0 form. At x equal to 1, this becomes 0 by 0, which is indeterminate form. And therefore, applying L'Hospital rule, limit x tends to 1 of 1 plus ln x minus x divided by 1 minus 2x plus x square equal to limit x tends to 1 of derivative of 1 plus ln x minus x divided by derivative of 1 minus 2x plus x square, which is equal to limit x tends to 1 of derivative of 1 is 0, derivative of ln x is 1 by x, derivative of x is 1. That is limit x tends to 1 of 1 by x minus 1 divided by minus 2 plus 2x, which is can be expressed as limit x tends to 1 of 1 minus x divided by x divided by minus 2 divided by 1 minus x. 1 minus x from numerator and denominator get cancelled. Limit x tends to 1 of 1 divided by minus 2x, which is nothing but minus 1 by 2. Second example, evaluate limit x tends to 0 of e raised to ax minus e raised to minus ax divided by ln of 1 plus bx. At x equal to 0, e raised to 0 minus e raised to 0 divided by 1 ln of 1 plus 0, that is 1 minus 1 divided by ln of 1, which is 0 by 0 form. Therefore, that is indeterminate form. Therefore, applying L'Hospital rule, limit x tends to 0 of e raised to ax minus e raised to minus ax divided by ln of 1 plus bx equal to limit x tends to 0 of e raised to ax minus e raised to ax dash, that is derivative of e raised to ax minus e raised to minus ax divided by derivative of ln of 1 plus bx, which is equal to limit x tends to 0 of a into e raised to ax plus a into e raised to minus ax divided by b divided by 1 plus bx. We will get a plus a divided by b, because a into e raised to 0, e raised to 0 is 1, plus a into e raised to 0, 1 divided by 1 plus 0, that is a plus divided by b, that is 2a by b. Evaluate limit x tends to pi by 4 of sec square x minus 2 tan x divided by 1 plus 4 cos of 4x. Sec square x minus 2 tan x divided by 1 plus cos of 4x. We know that sec pi by 4 is root 2 and tan pi by 4 is 1. Cos of 4x becomes cos of pi, which is minus 1. And if you substitute these values in fx by gx, it becomes 0 by 0, that is indeterminate form. Hence, applying L'Hospital rule, limit x tends to pi by 4 of sec square x minus 2 tan x divided by 1 plus 4 cos of 4x equal to limit x tends to pi by 4 derivative of sec square x minus 2 tan x divided by derivative of 1 plus cos of 4x, which is nothing but limit x tends to pi by 4 of derivative of sec square is 2 sec x and derivative of sec x is sec x tan x minus 2 times derivative of tan x is sec square x divided by derivative of 1 is 0 divided by cos of 4x is minus 4 sin 4x, which becomes limit x tends to pi by 4 2 sec x into sec x tan x minus 2 sec square x divided by minus 4 sin x equal to limit x tends to pi by 4 2 sec square x can be taken common, tan x minus 1 divided by minus 4 sin 4x, which is again 0 by 0 form. Therefore, applying L'Hospital rule, we will get limit x tends to pi by 4 of d by dx of sec square x into tan x minus 1 divided by minus 2 into d by dx of sin 4x. Applying UV rule for finding derivative of numerator, u into derivative of v plus v into derivative of u. Derivative of sec square x is 2 sec x into sec x tan x minus 1 as it is, plus sec square x as it is, and derivative of tan x is sec square x, derivative of 1 is 0, and minus 2 into 4 cos 4x, that is minus 8 cos 4x. This becomes limit x tends to pi by 4 2 sec square x tan x into tan x minus 1 plus sec square x into sec square x divided by minus 8 cos 4x. If we substitute value x equal to pi by 4, we will get it as 4 by 8, which is nothing but 1 by 2. Evaluate limit x tends to 0 of x square plus 2 cos x minus 2 divided by x sin cube x. This is 0 by 0 form. If we put x equal to 0, first term is 0, 2 cos 0 is 2 minus 2, that is 0, and denominator 0, therefore it is 0 by 0 form. We can apply directly L'Hospital rule. But before that, if we simplify this term, it will be easy for us. Limit x tends to 0 of x square plus 2x minus 2 cos x minus 2 divided by x sin cube x can be expressed as limit x tends to 0 of x square plus 2 cos x minus 2 divided by x into x cube multiplied by x cube by sin cube x, which can be expressed as limit x tends to 0 x square plus 2 cos x minus 2 divided by x raised to 4 into limit x tends to 0 x by sin x bracket cube. We know that limit x tends to 0 of x by sin x is 1. Therefore, this can be written as limit x tends to 0 of x square plus 2 cos x minus 2 divided by x raised to 4. Again, if we put x equal to 0, this is 0 by 0 form, and hence applying L'Hospital rule, we will get limit x tends to 0 derivative of x square plus 2 cos x minus 2 divided by derivative of x raised to 4, which is limit x tends to 0 of 2x minus 2 sin x divided by 4x cube, which is again 0 by 0 form. Therefore, applying L'Hospital rule, limit x tends to 0 of derivative of 2x minus 2 sin x, that is 2 minus 2 cos x, and derivative of 4x cube is 12x square. Therefore, it becomes limit x tends to 0 of 2 minus 2 cos x divided by 12x square, which is again 0 by 0 form. Applying again L'Hospital rule, limit x tends to 0 derivative of 2 minus 2 cos x divided by derivative of 12x square, which becomes limit x tends to 0 of 2 sin x divided by 24x. This is again 0 by 0 form. Again we apply L'Hospital rule. Limit x tends to 0. Derivative of 2 sin x is 2 cos x. Derivative of 24x is 24, which can be written as limit x tends to 0 of 2 cos x divided by 24. Cos 0 is 1. Therefore, substituting the value, we will get 2 divided by 24. 2 divided by 24 is nothing but 1 by 12. This is the answer. Friends, in this way, we can apply L'Hospital rule in multiple times also. Next problem. Limit x tends to 0 of sin 2x plus a sin x divided by x cube is a finite number given. Find a and then find the limit. Limit x tends to 0 of sin 2x plus a sin x divided by x cube. This is a 0 by 0 form. Applying L'Hospital rule, limit x tends to 0 of derivative of sin 2x plus a sin x divided by derivative of x cube. It becomes limit x tends to 0 2 cos 2x plus a cos x divided by 3x square. If we put x equal to 0, this term becomes infinite. But it is given as a finite term. In problem, this limit is given as finite. For it making it finite, we have to choose a such that it becomes indeterminate form and we can apply L'Hospital rule. For that, we choose a equal to minus 2. If we take a equal to minus 2, it will be 0 by 0 form, and applying L'Hospital rule, we will get limit x tends to 0, d by dx of 2 cos 2x minus 2 cos 2x divided by 3 into d by dx of x square, which is limit x tends to 0 of minus 4 sin 2x plus 2 sin x divided by 6x, which is again 0 by 0 form, that is indeterminate form. Applying L'Hospital rule, limit x tends to 0, derivative of minus 4 sin 2x plus 2 sin x divided by 6 into derivative of x, that becomes limit x tends to 0, minus 8 cos 2x plus 2 cos x divided by 6. And if we substitute the values, x tends to x at 0, we will get minus 8 into 1 plus 2 into 1 divided by 6. That is minus 6 by 6, which is minus 1. Therefore, limit x tends to 0 of sin 2x plus a sin x divided by x cube is minus 1 when a is chosen as minus 2. Dear friends, if you have not subscribed the channel yet, please subscribe the channel. Don't forget to press bell icon so that you can get the updates of this channel. Thank you. See you in next video.